In this video, we'll use the Joints tool to align a component to others in an assembly. These joints will also define the degrees of freedom by which these parts can move. Joints are enacted between components, but are defined by certain features within the component, like a body face or an edge. They ultimately define how components can move and animate, and they drive motion studies. So looking at our full mountain bike model, if I look down here at the bottom, I have a full assembly here that's got three sort of pivots, and a rocker that will need to align with those. So if I push the home view, I can see this a little bit better. So the first thing I want to do is align this rocker in the center of these two pivots here so that it aligns with the rest of the assembly. And to do that, the first one that I'm going to choose is a planar joint. And I'm going to select the outside face of my rocker. I'm going to click it a second time to confirm that I'm going to locate it there. And then I'm going to rotate around to look at the inside of this pivot here to make my component 2 selection. And when this happens, you'll see that it shows you an animation of the degrees of freedom that it's now inflicting on the model. And so we see that it's existing now on the same plane with the inside of the pivot here, but we don't want it to actually exist on the same plane. We want it to have some sort of offset. And to do that, I'm going to add to the offset option 0.65 millimeters, and that will center it between those two pivots. By clicking OK, we're going to exit out of the joint tool and clicking the home tool again. So if we take a moment to just move this rocker around, you'll find that it moves within the joint that we gave it, but it also moves the entire assembly. And so when you have really complex sets of joints going on, this is going to cause you a lot of problems because obviously you can't simulate exactly what's going to happen. This is kind of like saying, if you're in the space shuttle and you're trying to move around a linkage set, all of them are going to flop around everywhere. So we have to ground something. I'm just going to hit Control-Z to move everything back. And I'm going to ground this assembly here, which is our carbon frame. And to do that, I'm going to locate it in the browser, hide our joints here. And if I right-click on this frame, there's an option called Ground. And grounding it will put a little orange pin next to the icon that you can see here. And it'll fix all of those parts in space. And so now if I move my rocker around, you'll see that it can move around freely in space like we would expect it to without moving the rest of the assembly. And at the same time, it's honoring its joint that we've made and keeping it centered between those two pivots. So the next thing I want to do is align this front shaft of the rocker with the bolt that it will go around. And to do that, I'm going to make another joint. Let's say continue. And I'm going to choose the cylindrical type of joint. And this will basically let me select two different curvatures for my two components. And from those curvatures, it'll make them concentric with each other. So we now have a cylindrical joint. And you'll find that as it's animated here, it's no longer honoring the planar joint that we chose before, right? It's moving inside and outside of that plane that we defined. This is because anytime you add a joint, it's going to show you the degrees of freedom that it's constraining it by adding to that joint. And so when we hit OK and finish this joint, it's going to begin honoring both joints, but right now it's only showing me how my degrees of freedom are going to change for this particular part. So now I can say OK, and we'll see now that it's moved between two joints, and if I rotate this, it stays within the plane that we defined with our first joint, and it also stays moving around that particular bolt as defined by our second cylindrical joint. So the next thing I want to do is align the shaft of the elbow of the rocker here with the pin that comes out of the pivot. And to do that, I'm going to make another joint. And again, it's going to be cylindrical. And I will choose the inside of that shaft there. And then I'll choose the circular edge of the pivot and choose a cylindrical joint and say OK. And now if you look and move the rocker here, you'll see that we begin to have a motion that honors all three of the joints that we've created so far. So the last one to do is just the back there where we have this back end of the rocker with the pivot in the back there for the shock assembly. And to do that, we're going to make a third cylindrical joint. So I can rotate around the back here. Joint, say OK. And for this one, I'm going to choose this sort of outer edge of the rocker as well as the outer face of the pin there. And then I'll say OK. So now that we have all of our joints in place, I can look at the front view and you can begin to see how we have these joints that are moving in conjunction with each other and they're being defined that way in space. So again, unlike aligning that just moves things there, This moves them and keeps them there however we define them in the joint. If you ever need to go back and change or edit a joint, you can either do so by looking in the joints folder of your browser or on the timeline, and by right-clicking on any joint, you can go through and say Edit Joint, and that will bring up all of the properties that we worked on previously. From the same place, you can also go through and drive the joints, you can edit the joint limits, you can lock joints in place, and you can suppress joints. And if you look beside each joint, there's a little light bulb, and these light bulbs, like everything else in Fusion, show and hide them. However, they do not suppress the joints. So this is just showing and hiding the indicators of the joints, which you see here is these little flags that come up. But by turning those off, you're not suppressing the joint or making it no longer effective. To do that, you right-click and say Suppress. Just to go over really quick the other joints that we have available, we can look in the Joint tool. And a rigid group you learned about a little bit earlier. It's just grouping things together so that they're fixed in space in relation to one another. Revolute joints are going to be between some sort of point on an object, and it's going to revolve around something else that's defined at another point. Slider joint is for something that you kind of picture being like a tripod, for instance, where you have a leg that slides outside of another leg. The pin slot joint is going to be a pin that's working inside of a slot, so it's going to keep it contained within a certain geometry and move it along that geometry. And a ball joint is going to be a ball that's in some sort of socket. So those are the different options that you have, and by doing that you can create a really complex assembly that goes through a very defined mechanical motion.